Welcome to the deep dive. Today we're going to be looking at cybersecurity news. Specifically, we're going to be taking a look at the role of large language models in cybersecurity. So when we talk about large language models, we're talking about AI that can read and write and code like humans, right?
Yeah,
And we're seeing these LLMs being used all over the place in cybersecurity.
absolutely.
And, obviously that comes with a whole bunch of opportunities, but it also comes with a ton of risks.
It really does.
So we've got a stack of research papers here, straight from the Arxiv preprint server, and we're going to be dissecting some of these papers to really get a better understanding of what's going on in this space.
It feels like every day there's a new breakthrough, and a
Yeah.
new vulnerability.
Yeah, absolutely.
It's a really exciting time to be in cybersecurity.
So let's start with the good stuff, all right? Let's look at some of the positive ways that LLMs are being used. One paper, Large Language Models in Software Security. A survey of vulnerability detection techniques and insights suggests that LLMs might completely change how we find weaknesses in software.
Yeah, I mean, just imagine having this AI that can not only spot security flaws,
Yeah.
also suggest fixes for them.
Yeah.
Traditional methods are pretty slow and they often miss things.
Yeah.
LLMs, on the other hand, they can analyze code in a much more nuanced way. They can spot patterns and anomalies that humans would probably miss.
That sounds incredible, right? It's almost like having this AI security guard that's patrolling your code 24/7.
Yeah, exactly.
But of course, with every silver lining, there's a cloud, right?
Another paper, JB Shield, defending large language models from jailbreak attacks through activated concept analysis and manipulation, warns us about something called jailbreaking LLMs.
Yeah, and this is a big concern.
Because it means you can trick an LLM into doing something that it's not supposed to do.
Right.
Generating harmful content or giving away sensitive information, even when it's programmed not to.
Right.
It's finding this back door into the AI's brain.
Right.
Researchers are working on defenses like this JB Shield framework,
Yeah.
but it's a constant arms race.
Yeah.
You're always trying to stay one step ahead.
So we've got LLMs potentially fixing vulnerabilities.
Right.
And we've got LLMs being exploited themselves.
Yeah.
What about that kind of gray area in between?
Yeah, well, there's definitely a middle ground, right? There's
Yeah.
this fascinating study, Scalable and Ethical Insider Threat Detection Through Data Synthesis and Analysis by LLMs, that looks at how we can use LLMs to detect insider threats.
Ooh, insider threats. That's
Yeah.
a chilling thought, right? You're talking about employees or contractors
Right.
who might intentionally try to sabotage a company from within.
Exactly. It's a tough problem to address.
Yeah.
Traditional methods are usually super resource intensive and they can raise all sorts of privacy concerns.
Right.
But this research suggests that LLMs might actually offer a more scalable
Yeah.
and a more ethical way to spot these potential threats
Okay.
by doing things like analyzing employee sentiment in online reviews or in internal communications.
So instead of spying on employees, we could have AI sort of reading between the lines
Right.
to see if somebody's about to go rogue, essentially.
Yeah, it's early research, but
Yeah.
it just highlights the really nuanced ways that LLMs can be applied to these security challenges.
It feels like we're barely scratching the surface here, though, right? What else is coming out of the research world?
Yeah, there's a ton of stuff. It's like a flood of innovation.
Okay.
For example, there's this paper called SAFE, Self-Supervised Anomaly Detection Framework for Intrusion Detection.
Okay.
And it introduces this framework called SAFE.
Okay.
And what SAFE does is it teaches LLMs to recognize what normal network behavior looks like,
Right.
and then it flags anything unusual.
So it's like a proactive approach to security.
Exactly.
Right. You're not playing catch up with the latest malware.
Yeah.
You're teaching the AI to recognize suspicious activity no matter what form it takes.
Right, exactly.
That's impressive.
Yeah, it is.
But what about malware itself? I mean, LLMs are got to be playing a role there too, right?
Oh, absolutely.
Okay.
There's a paper called Roma Robust Malware Attribution via Byte-Level Adversarial Training with Global Perturbations and Adversarial Consistency Regularization.
Okay.
It's a mouthful, but basically it describes this new technique called Roma
Okay.
that uses LLMs to figure out where malware came from.
Attributing malware. Okay.
Yeah.
So we're not just talking about what the malware is. We're talking about who's behind it.
Exactly, exactly. And the cool thing about Roma is that it's designed to be a lot tougher than previous methods.
Okay.
Hackers, they try to disguise their malware by making these tiny little changes to the
Yeah.
code. But Roma uses something called adversarial training to make the LLM way harder to fool.
Okay. So it's like giving the AI detective special training to spot even the most cleverly disguised criminals.
Exactly.
I like that analogy.
Yeah, it's like Sherlock Holmes for malware.
I'm seeing a theme here. It seems like LLMs are becoming these incredibly versatile tools in the cybersecurity world, right? They can be used defensively,
Yeah,
offensively, and even for investigations. It's
absolutely.
pretty remarkable.
Yeah, and the innovation is just exploding.
Yeah.
We're seeing LLMs being used for everything from like automated penetration testing to building honeypots that specifically target AI-powered attacks.
Wait, hold on. AI agents conducting penetration tests?
Yeah,
That sounds like something straight out of like a cyberpunk novel.
it does, doesn't it?
It's wild.
But it's closer than you think. I
Okay.
mean, these AI agents, they're trained to think and act like human penetration testers.
Yeah.
They probe systems for weaknesses.
Yeah.
They identify vulnerabilities,
Uh-huh.
but they do it much faster and more efficiently than a human could.
And these AI-powered honeypots. So those are basically traps that are set to lure in and study these malicious AI agents.
Exactly, yeah. It's
Okay.
like, imagine setting a trap that only attracts AI attackers.
Right.
Right? It lets researchers see how these AI-powered attacks actually unfold in the wild.
Right.
It gives them these valuable insights into their tactics and their techniques.
That's incredible.
It is, yeah.
This is all fascinating, but it also feels like we're kind of venturing into this uncharted territory, right? I mean, we don't really know what the long-term implications of all of this are going to be.
We are, yeah. It's very early days.
Yeah.
And as with any new technology, there are downsides and there are challenges.
Okay.
One paper that I thought was particularly interesting is called Automated Consistency Analysis of LLMs.
Okay.
And this paper raises some concerns about the reliability of LLMs.
Consistency analysis.
Yeah, consistency analysis.
What's that all about?
Basically, it boils down to trust. you know,
Okay.
Can we trust these LLMs to make the right decisions about security vulnerabilities
Yeah.
or potential threats?
Uh-huh.
The researchers found that LLMs can actually be inconsistent in their responses.
So you ask it the same question twice, you might get two different answers.
Exactly, even when you ask them the same question multiple times.
Wow.
So, it raises these serious questions about their reliability.
Yeah.
Can we really trust them if their answers aren't stable?
So it's not all sunshine and roses with these LLMs, right?
No.
There are some very real limitations that we have to consider
Absolutely.
as we start to integrate them into our cybersecurity systems.
Yeah, and it highlights how important ongoing research and development is.
Yeah.
We need to make sure that these powerful tools are being used responsibly and
Yeah.
effectively.
Yeah, we need to proceed with caution.
Absolutely. It really is a bit like the Wild West out there with LLMs right now.
Yeah.
We're seeing this huge gold rush of innovation, but there's also a lot of uncertainty about the risks and the unintended consequences.
And with great power comes great responsibility, right?
Exactly.
It seems like every time we find a new way that LLMs can improve cybersecurity, we also find a new way they can be exploited
That's a good point.
or misused.
Yeah, that's exactly right. Take this paper, for example, scalable fingerprinting of large language models. This research looks at the idea of fingerprinting LLMs.
Fingerprinting.
Yeah.
So like a digital fingerprint
Uh-huh.
that can identify a specific AI.
That's the idea. Imagine being able to tell if a piece of text or code was created by a human or by an AI, or even tracing like malicious code back to the exact LLM that generated it.
That would be huge for accountability, right?
It would.
But I can also see how it could raise some serious privacy concerns.
Oh, absolutely.
Yeah.
Imagine someone's writing style being so closely tied to a particular LLM
Yeah.
that it could be used to track them online or even identify them.
Right. Right.
It's a double-edged sword.
It is. Yeah.
It always is.
And what about the potential for LLMs to like manipulate data
yeah.
or even erase data? That's a scary thought.
It is, and there's this really interesting paper called Unstable Unlearning, the hidden risk of concept resurgence in diffusion models,
Okay.
and it delves into that very issue.
Unlearning. So trying to make an AI forget certain information.
Exactly. Think about removing, copyrighted material from an AI's training data,
Right.
or maybe preventing it from generating harmful content. The idea is to sanitize the AI's knowledge, make sure it's not going to do anything bad.
Right. Right. So it's a good thing.
Yeah, in theory it is. But this research shows that unlearning isn't as easy as we might think.
Okay.
They found that even after an AI has seemingly forgotten something, it can still resurface later on,
Really?
especially if you keep training the model on new data.
So even after you try to scrub an AI clean,
Right.
there's a chance that like old, potentially harmful knowledge could come back.
It's possible, yeah.
Wow. That's troubling.
It is, yeah.
It's like
It's like a bad habit that you just can't quite shake.
it's like a digital ghost that's haunting the AI.
That's a good way to put it.
So we've got jailbreaking, we've got data manipulation, And now we've got this unstable unlearning thing.
Right.
It seems like using LLMs in cybersecurity really requires us to be extra careful and extra vigilant.
It does, yeah. And that brings us to another really important topic, AI bias.
Okay.
There's the study Err on the Side of texture bias on real data, and it shows how these subtle biases in AI systems can actually create security vulnerabilities.
We hear a lot about bias in AI generally.
We do.
How does it play out specifically in cybersecurity?
Well, in this case, the researchers found that some AI image recognition systems have this thing called texture bias.
Texture bias, okay.
Yeah, so they might misclassify images based on the texture of the objects rather than like the shape or the actual content of the image.
That seems counterintuitive, right? I mean, wouldn't an image recognition system want to pay attention to both the texture and the shape of an object?
You'd think so, right?
Yeah.
But this over-reliance on texture can actually create these really exploitable security holes.
Okay, so, like, how would that work in practice?
Well, imagine an attacker, who wants to bypass a security camera.
Right.
They could potentially exploit this texture bias by, like, slightly altering the texture of their clothing or their surroundings to trick the AI into misclassifying them.
So a security camera with texture bias might be fooled by an attacker who's wearing, like, a specific camouflage pattern.
Exactly.
Wow, okay, so even these subtle biases can have really real-world consequences
They can, yeah.
for security.
It just highlights how important it is to be aware of these biases and to mitigate them as much as possible.
Yeah, absolutely.
At the end of the day, these AI systems are only as good as the data they're trained on.
Right.
And if that data is biased, the AI is going to be biased too.
So it's not just about the AI itself, it's also about the data that's feeding the AI. And how we collect that data and how we make sure that it's as representative and unbiased as possible.
Yeah, we need to be thinking about the whole pipeline.
Right.
From data collection to model training to deployment.
So we've got a lot to consider here. Jailbreaking, data manipulation, bias. It's clear that using LLMs in cybersecurity requires a lot of careful thought and constant vigilance.
It does, yeah.
It's not something we can just take lightly.
No, we can't just assume that these LLMs are going to be a silver bullet solution.
Right.
They're powerful tools, but they're still just tools.
Right.
And it's up to us to use them wisely.
Yeah, we need to be smart about how we integrate them into our security systems.
Absolutely.
And make sure that we're not creating more problems than we're solving.
That's a good point. And it brings us to another important paper that I think is worth highlighting. This one is called Fuzzy to Clear: Elucidating the Threat Hunter Cognitive Process and Cognitive Support Needs.
Okay, that's a mouthful.
It is, yeah.
What's that one about?
So this paper focuses on the cognitive processes of threat hunters.
Threat hunters, those are the people who are like, on the front lines of defense.
They are, yeah.
They're the ones who are actively searching for and neutralizing threats.
Exactly. They're the ones who are proactively trying to find the bad guys before they can do any damage.
Right.
They're like the detectives of the cybersecurity world.
I like that.
They're constantly trying to outsmart the attackers and stay one step ahead.
So what did this research uncover about how threat hunters think?
Well, the researchers found that threat hunting is a really iterative and creative process.
Okay.
It often starts with this vague suspicion.
Yeah.
Or maybe just a few scattered pieces of data that don't seem to add up.
Uh-huh.
And then the threat hunters use their expertise and their intuition to kind of build this mental model of the threat.
Okay.
They're slowly piecing together this clearer picture of what's happening.
So it's not just about following a checklist or running some automated scans?
No, it's much more nuanced than that.
Okay.
It really requires human judgment and ingenuity.
That's fascinating.
It is, yeah.
So it seems like even in the age of AI, human expertise is still absolutely essential for effective cybersecurity.
Absolutely. We can't just replace humans with machines.
Right.
We need to make sure we're developing tools and technologies that actually support this human-centered approach to security.
So tools that can help analysts visualize data, explore hypotheses, and collaborate with each other more effectively.
Exactly.
It's a good reminder that we need to be thinking about augmenting human capabilities, not replacing them.
I agree, yeah.
And that principle applies to more than just threat hunting, right? I mean, as we integrate LLMs into more and more security applications, we need to make sure that humans are still in the loop.
Absolutely. We need to make sure that humans are still making the decisions and providing oversight.
It's about finding that right balance, right?
It is, yeah.
Between the power of AI
and
the wisdom of human experience.
Well said.
Okay, so we've talked a lot about the risks of LLMs.
We have.
But you also mentioned some really exciting new developments in cybersecurity.
I did, yeah.
Like AI deepfake detection and quantum-resistant cryptography.
Those are definitely topics that deserve their own deep dive.
Yeah, I think we could spend a whole episode on each of those.
We could.
It seems like every time we peel back a layer of the cybersecurity onion, We just find a whole new set of challenges and opportunities.
That's true.
It's a wild ride,
It is, yeah.
but it's also incredibly important work, right?
Oh,
I
absolutely.
mean, cybersecurity is becoming more and more critical every day
It is, yeah.
as our lives become increasingly digital.
And that's why it's so important for everyone to stay informed and engaged.
Yeah, even if you're not a cybersecurity expert,
Exactly.
you need to have at least a basic understanding of the threats that are out there and the steps that you can take to protect yourself.
And that's what we're trying to do here with the deep dive.
Yeah, exactly. We're trying to make cybersecurity accessible to everyone.
Right, to demystify it a little bit.
Yeah, exactly.
Because at the end of the day, we're all in this together.
Yeah, we are.
We all have a role to play in keeping ourselves and our data safe.
All right, well, on that note, I think it's time to wrap up this deep dive.
Okay.
Thanks for joining us.
Thanks for having me.
And until next time, stay safe out there in the digital world. We've covered so much ground in this deep dive, like from AI detectives to AI bias, but it's all been pretty high level.
Yeah. It is important to connect the dots back to the listener, right?
Right.
I mean, a few of these papers we've looked at have direct implications for you, the listener, and how you interact with technology and protect yourself in this LLM-driven world.
Okay, let's get personal then.
Okay?
What do people need to know to stay safe out there?
Well, one paper that really stood out to me was DROP, Poison Dilution via Knowledge Distillation for Federated Learning.
Okay.
Now remember, we talked about federated learning earlier. That's where multiple parties train an AI model together without directly sharing their data.
Right, like that hospital example,
Exactly.
where they can train a model to improve diagnosis without exposing sensitive patient data.
That's the one. Now DROP focuses on protecting this process from poisoning attacks.
Poisoning attacks.
Yeah. Imagine someone tries to sneak bad data into the training process to corrupt the model.
Oh, so it could give bad results.
Exactly. DROP acts as a filter to dilute the impact of this poisoned data and protect the integrity of the collaborative learning.
So like an immune system for AI.
You got it.
Cool.
And here's why it matters to you. As federated learning becomes more common, you might actually be participating in these training processes without realizing it through your smartphone or other devices.
Wait, my phone could be helping to train an AI right now without me knowing.
It's possible.
That's kind of creepy, but also really cool.
It is, yeah.
So this drop research is important because it helps make sure these processes are secure, even when you have these bad actors trying to mess things up.
Exactly.
Okay, drop. I'll remember that one.
All right.
What else can I do to protect myself in this brave new world of LLMs?
Well, another paper with some practical advice is distributed non-interactive zero-knowledge proofs.
Okay, that sounds complicated.
It does, but it's really about empowerment. Imagine proving your identity or your right to access something online without revealing any personal information.
Oh, that's a constant struggle, right?
It is.
Like prove I'm over 18 without giving away my birthday, that kind of thing.
Exactly. And distributed zero-knowledge proofs offer a way to do that. You prove something is true without revealing the underlying data.
Okay.
And it's decentralized, meaning you don't have to rely on one single company or authority to verify your claim.
So it's like a secret handshake.
Yeah.
Only you and the other party understand. So you can prove you're in the club without showing your membership card.
That's a great analogy.
Okay, like that distributed zero-knowledge proofs.
Yeah.
Definitely going to look into that one.
All right.
Anything else?
One last paper I wanted to touch on is Private Low-Rank Approximation for Covariance Matrices, Dyson-Brownian Motion, and Eigenvalue Gap Bounds for Gaussian Perturbations.
Okay, another mouthful.
I know, right? But this one dives into something called differential privacy.
Differential privacy, okay.
Yeah, and I'm sensing a theme here.
Yeah, what's that?
It seems like a lot of this research is about how to work with data without actually exposing the data itself.
Right, right.
And differential privacy is a perfect example of that.
Okay.
It lets researchers analyze data and get useful information without compromising the privacy of individuals.
So like studying health trends based on medical records, but without revealing anyone's actual medical information.
Exactly.
Wow, that's amazing.
It is, yeah.
So it's like finding trends in the stars without knowing the names of the individual stars, right?
Exactly. And as LLMs become more sophisticated at analyzing data,
Yeah.
techniques like differential privacy will be essential to protecting our privacy.
Wow, we've gone from AI that can write code to AI that can protect our privacy while analyzing sensitive data.
I know, it's pretty incredible.
It really is quite a journey.
It is.
So much to think about.
There is.
I feel much more informed, but also a little overwhelmed by all this information.
It's a lot to take in.
It is. It is.
But what's the one thing you want listeners to take away from this deep dive?
That's a good question. I think the biggest takeaway for me is that LLMs are powerful tools, but they're still tools.
That's a good way to put it.
They can be used for good or bad.
Yeah.
And it's really up to all of us to understand their capabilities and their limitations so we can use them responsibly
I agree.
and safely.
Yeah. Knowledge is power, right?
Yes, absolutely.
The more you know about LLMs, the better equipped you'll be to navigate this rapidly evolving landscape.
Right. Well, thanks for guiding us through this complex landscape and equipping us with the information we need to navigate it.
It's been my pleasure.
Really appreciate it. All right, that's all the time we have for today's deep dive. Thanks for joining us, and until next time, stay safe in the digital world. 22-4.